In section 10.7, we're going to solve radical equations. There are three types of radical equations we're going to solve. Those that have a single radical, those that have a single radical, but they end up being a quadratic equation that will have to be factored, and then those equations that have two separate radicals. So we'll talk about those. Now, in this particular section, as you're working through your ALEKS equations for square root equations, you should not be solving anything bigger than a square root. If you are asked to solve an equation that has a cube root in it, please notify me so I can go in and check on that. So in order to solve a radical equation, if you only have one square root, first thing you want to do is isolate the square root. So here I have one square root of x, which means I want to isolate the square root of x. Now, in order to do that, I'm going to add 3 to both sides. So that gives me square root of x equals to 10. And once I get the radical isolated, what I'm going to do is I'm going to square both sides, because the square will cancel the square root. And once I cancel the square root, I have x equals to 100. Now, you always need to check your answers, because some of these answers are going to be no solution answers because you cannot have a negative number under your radical. So when I check that 100 answer, I'm going to take the square root of 100, subtract 3, and I should get 7. The square root of 100 is 10. 10 minus 3 does equal to 7, so my outcome, my final answer would be 100. In example number 2, you can see where they have moved the 4 to the other side by subtracting it. You can see where they have squared both sides. Make sure that you do check your answer. So when you check your answer, you should take the square root of 25 plus 4, and that should give you 9. 5 plus 4 does give you 9, so 25 would be your answer. In example 3, I need to isolate my radical, so I'm going to subtract 1. That gives me square root y equals to 3. I'm going to square both sides to get rid of the radical. That square knocks that square root out, and I end up with y equals to 9. That's what I think my answer is. So when I check my answer, I have 1 plus square root of 9 should give me 4, and 1 plus 3 does indeed give me 4, so my answer checks. What you do not want to do is keep an answer that when you plug it back into your square root, the number under your square root becomes negative. Those are not real numbers, and we'll talk about those in a little while. Now, this has one radical. Even though it has p minus 4 under it, it still has one radical. So we're going to isolate the radical by subtracting 7 from both sides. And that gives me square root of p minus 4 equals to 3. Once I get to there, I'm going to square both sides to get rid of the radical. So that gives me p minus 4 equals to 9. Then I'm going to add 4 to both sides, and I get p equals to 13. Now I can keep 13 as long as when I check my answer, when I plug 13 in, as long as 13 minus 4 is not a negative number, I'm okay. 13 minus 4 is square root of 9. I can take the square root of 9 because 9 is positive, so 3 plus 7 does equal to 10. So p equals 13 would be my solution to this problem. In example 5, the radical is already isolated, so I don't have to move anything like I've had to do in previous problems. I can go straight to the squaring of both sides. That square will knock out that radical. That gives me 5y plus 1. 4 squared is 16. I am going to subtract 1, and that gives me 5y equals to 15. When you divide by 5, y should equal to 3. Hopefully that is my answer. So when I check my answer, I get 5 times 3 plus 1 should equal to 4. 5 times 3 is 15. 15 plus 1 is square root of 16, and square root of 16 does equal to 4. So y equals 3 is my answer. Now, those are the first type of equations where you have one equation or one radical that you have to isolate and go through the steps of squaring both sides and then solving the remaining equation. The next two examples, notice that I've crossed out anything that's not just a square root. Okay, so the next two examples has a radical equal to a radical. So in this particular problem, all I have to do is, if I have two radicals, I'm going to separate them, and the squares will knock out the radicals. So I'm going to solve x plus 2 equals to 2x minus 6. So that would be x equals to 8. Now, as long as when I plug in 8 into the original problem, the two sides balance, then I am okay. So when I check my answer for the first problem, square root of 8 plus 2 should equal to the square root of 2 times 8 minus 6. Not 16, but 6. That would be square root of 10. We're going to do the same here. I'm going to take the square root of both sides. The squares cancel the radicals. 3y minus 4 equals to y plus 12. I'm going to move 4 over, bring y to the front, move 4 to the back, so that would be 2y equals to 16. So here again, y equals to 8. As long as when you plug 8 in, you get the same answer on each side, that would be your final answer. What you don't want is to plug in 8, like 8 plus 12, if that had turned out to be a negative, which it doesn't. But if it does, you would have no real solution for this problem. Now, here are a few examples where there is no solution. So what we're going to do is going to do the same thing. We have one radical. We're going to subtract 8 from both sides. To isolate the radical, that gives me square root b plus 3 equals to negative 2. When I square both sides, the square cancels the radical. Negative 2 squared is positive 4, not negative 4. And when I subtract 3, I get b equals to 1. Now, when I go to check my answer, I get 8 plus 1 plus 3, and that should equal to 6. That's 8 plus the square root of 4 should equal to 6, and 8 plus 2 does not equal to 6. So therefore, I do not have a solution to this equation. The next example, example 10, is also going to be a no solution scenario. If you notice, number 9 is also a no solution. So here, isolate your radical. In number 10, we're going to subtract 10 from both sides. That gives me negative 5 equals to square root of 2x plus 1. I'm going to square both sides. Once I get my radical isolated, the square and the root cancel. So on the right, I get 2x plus 1. Negative 5 squared is positive 25. I'm going to subtract 1 from both sides. That gives me 24. So x equals to 12. When I plug it in, the two sides will not balance since we are showing the no solution scenarios. So when I check my answer and plug 12 in, that's 5 equals 2. 2 times 12 plus 1 plus 10. 2 times 12 is 24. 24 plus 1 is 25. And when I take the square root of 25, I get 5 plus 10, and 5 plus 10 does not equal to 5. So I have no solution for this problem. So there are a few examples of no solution scenarios. Now, The last example, we're going to end up with a quadratic that has to be factored. Now, if you notice, there is one radical. It is already isolated. So in order to get rid of a radical that is isolated, we're going to square both sides. But in doing so, that gives me y squared equals 2y plus 2. So I'm going to set equal to 0. So I'm going to rewrite it as y squared minus y minus 2 equals to 0. When you move these to the other side, you have to subtract them. Then I have to come up with factors of negative 2 that subtract to give me negative 1, which would be negative 2 and positive 1, because 2 and 1 are the only factors of 2. Once I get my factors, I'm going to set each factor, y minus 2 equals to 0, solve that, y plus 1 equals to 0, and solve that. So y equals to 2 and y equals to negative 1. Now, it is very important that you check in order to make sure that you can keep both answers. What we're going to do is we're going to go back to the original problem, which is y equals to square root of y plus 2. I'm going to plug 2 in first. 2 equals to square root 2 plus 2. And 2 does equal to the square root of 4. So I can keep y equals to 2. But watch what happens when I try to plug in negative 1. Negative 1 equals to square root of negative 1 plus 2. That's negative 1 equals to the square root of 1, and that is not true. So although I was able to factor and get two answers, I cannot keep both answers because one of them does not work when I plug it back into the original problem. Here is our final example out of section 7. So solving the radical equations, this is also going to give me a quadratic. So since my radical is already isolated, I'm going to square both sides to get rid of it. So this gives me x squared. That square and that radical will cancel. I'm going to set it equal to 0 just like we did before. So x squared minus 5x plus 6 equals to 0. The factors of 6 that add up to 5 are x minus 3 and x minus 2. Set each factor equal to 0. Sorry for the dogs barking. The Cook's Pest Control guy just came here, so they're going crazy. X equals to 3 and x equals to 2. Now, I have to plug both of those in to make sure that my answer is legit. The original problem was x equals to the square root of 5x minus 6. So I'm going to plug 3 in first. 3 equals to the square root of 15 minus 6. 3 equals to the square root of 9, and that is correct. I'm going to plug 2 in and see if I can get it to balance so I can keep the answer x equals 3. So 2 equals to the square root of 5 times 2, which is 10, minus 6. 2 equals to the square root of 4. That is correct. So this time I get to keep both answers. I do not have a throwaway answer like I did in one of the other problems. Now, there were 3 types of equations. One with a single radical that you isolate, get rid of, or isolate, square both sides, and then get rid of the radical and solve the equation. Make sure you always check. The third or the second example was if you have 2 radicals equal to each other, you just square both sides, solve the remaining equation. And the third example is if you have a single radical, but it ends up being a quadratic. You have to isolate the radical, set the quadratic equal to 0, factor it, solve those 2 factors, and then make sure that you do check your answers. Now, if you have any questions, please make sure that you do contact me via email or Remind, and we can work through any issues that you have.